Let's discuss the question number 39 from test 3, theory of machines. The topic is theory of machine. So a linear harmonic oscillator having mass 1.1 kg is set into motion with viscous damper, and the frequency of vibration is 10 Hz. So let's draw a spring mass damper where K is the spring constant, C is the damping. The frequency of vibration is given as 10 Hz. Okay, so instead of giving K, he has directly given the frequency of vibration. And now if you set this into motion, the response of a spring mass system with a damper in the underdamping case will be something like this. The amplitude decreases for a period of time. Okay, so now the two successive amplitudes, let that be at xn and xn plus 1. So now we have a relation when we derive the response for this spring mass system. The difference in the two successive amplitudes is basically given by this equation. Okay, where this is my damping ratio, zeta. This is my frequency of vibration, the natural frequency of vibration. And this is my damping period. So the damping period is again expressed in terms of zeta as 2 pi by, so this is basically expressed as 2 pi by omega d, and then omega d is again, the damping frequency is again represented in terms of omega n as in this way. So these are all the things when we derive the response. These are all we study these all formulas at that time. So just substitute all that and get xn by xn plus 1. So it's basically of this form, 2 pi by zeta by root over 1 minus zeta square. Okay, so now xn is given as 4.65 mm and this is given as 4.30 mm e power 2 pi zeta by 1 minus zeta whole square. If I take ln on both sides, so I get 4.360 by 2 pi zeta by 1 minus zeta square. So this I have to use a calculator, and this value comes to be 0.07825 2 pi zeta by 1 minus zeta whole square. So from this I can find out zeta by small simplification, and I get a value of 0.0245. So it's just you have to use a calculator. And now the damping coefficient is what is asked. So damping coefficient is again related to zeta by this formula, 2 chi m omega n. So after substituting all these values into mass is basically 1.1 into omega n is 2 pi into frequency, which is 10 Hz. So this, if I simplify, I get 1.72 ns per meter. So the answer is B. Thank you.